the organizer for this nice invitation. Then a message, personal message to Professor Luglio and the organizer again is that in the past, in the not, let's say, so old past of my professional career, I was the special advisor of the European Commission on space policies, supporting the commissioner at the time and vice president of the European Commission, Mr. Antonio Tajani, who is now the president of the parliament. So I had the chance to speak with him recently, and I mentioned the fact that there was this conference, and it's nice to know that he was very pleased of this initiative for two reasons why. First of all, because he's fond of space and innovation and technology, but also because of the nature that you explained very well this morning, that this conference is also based on the international cooperation, especially with countries in the Mediterranean area and Africa. And this is a topic very dear to the European Union these days. So we are, let's say, you are somehow morally supported by the whole of the European Union. Okay, about my presentation, I will speak about, more generally than just a synchronization, about the integration and fusion of PNT. By the way, the acronym stands for Positioning, Navigation, and Timing. Okay, yes. And I have to go with the arrows. Yeah. Remote sensing and telecommunications. I use the word infrastructures rather than systems because, in fact, these systems are becoming worldwide. They tend to cooperate at a global level, and they are also characterized more and more by a very strong service orientation. And this makes them a sort of infrastructures, because what we today, as users now, not as engineers, what we get from the three words of navigation, and positioning, and timing, remote sensing, is in fact considered as a sort of utility. Okay, so these infrastructures, although heavily based on technology, very advanced technology, but from the user point of view, is at the same level as the electric power distribution network, which is also, by the way, very complex, but we users consider it something that is natural. We consider it something for granted, almost granted. So the summary of my presentation. I will start, by the way, I have to thank my colleague Antonio Franchi for his tremendously effective presentation that introduced very much and very well the matter of ubiquity, and in particular on telecommunications. I will extend to, let's say, the ubiquity to, in general, connectivity, so telecommunications, fixed and mobile. I will also speak about ubiquitous sensing, remote sensing, sensing in general of the world around us, and I will speak about the ubiquity in localization and timing. Ubiquity, localization, and timing, I anticipate, is global positioning system. You know this word, but now the picture is more complex. Which are the transitional processes that our society is experiencing? First of all, the integration and fusion at space, because I come from the European Space Agency, so allow me to speak a bit also about satellites and space, of space and ground technologies, and infrastructures, because it's a cooperation at technological level and infrastructural and system level, which let's say, bring us to many important results at society level, but one, for instance, I will expand on it, is a completely new representation of our world, a new mapping. I will anticipate this word. Another important process, unfortunately I will not expand that much on it because we do not have time, is the progressive dematerialization of our economy and our products, and the transformation of products, let's say material products, into services. What it is called, with a very bad word, I don't like it, servitization. Okay? This, at the end of the day, is bringing us to a new world that is digital, yes, and it is characterized by these two key words that are integration and fusion. So let's well, this, I don't think I have to explain to you the exponential growth of the digital technology everywhere. But the figures, I think, speak by themselves. We deal only now with billions and trillions, whatever you mention, in terms of connection, in terms of bits per second, or in terms of dollars or euros. Nothing less than 1 billion is accepted. Okay? There is enormous quantity of things that are moving about the digital world, and this is a fact. Now, specifically, we mentioned several times today 5G, and I refer back to the presentation by Antonio Franchi. Many people have different views about what 5G is. The first and most simple one is the 5th generation, as simple as that. Today we are in the 4G, the next will be 5G. But personally, and the picture explains it, I think that it is more than that. It is maybe, but there is a good hope about it, the first attempt to have a holistic and systemic view of the telecommunication infrastructures. Because the ambition is so large, ambition in terms of everything, in terms of frequencies. You see that 5G will span from 300 megahertz up to 300 gigahertz. Ambition in terms of data rates, because we go from a few bits per second up to several tens of gigabits per second. And in terms of typology of networks and cells. So we go from the picocells up to the macro cells. And this type of approach doesn't work if you do not approach it in a systemic view. And this is what 5G is trying to do. Whether they will succeed, I hope so. Here it's not shown the satellite, but you'll see that the satellite has a role in it, as it was mentioned. By the way, I associate immediately to 5G the matter of Internet of Things. Why? Because if you want Internet of Things, machine to machine, but Internet of Things just to explain the word of things that are now intelligent and connected together. Because somehow the two technologies feed one the other. Because IoT is generating a huge amount of data that have to be transmitted in real time, or in any case very quickly and effectively. And so it needs 5G, and 5G is allowing also IoT. So the one is feeding the other. And we know very well, by the way, in the next days and presentation, people more entitled than me will explain what 5G is, what the potentiality are. IoT is going to, together with 5G again, the two together are going to enter into many areas of our society. Okay, so it's important not to forget. I'll come back to the matter of Internet of Things. And satellites. I just referred to the previous presentation, but it is true that satellites can have a role. Can have a role that is, you could consider it a niche role, but also an enabler of 5G, because in fact the full ubiquity will not be achieved if you don't have satellites. And satellites, as it was mentioned, are also important to guarantee the resilience, to guarantee the security of the transmission of data. So in many particular areas, without satellites, 5G probably will not work. It would be just a sort of nominal type of approach. So satellites are there for sure. Then I mentioned in the title remote sensing. Now, being at the European Space Agency, I have to speak also because it is a very successful case. And by the way, I like also to mention the support of Italy. Let me open a little parenthesis. In the three topics that I have in the title, in fact, there is also a summary of my professional career, because as Professor Luglio anticipated, I started working, in fact, on telecommunications. The first constellations of satellites, Globastar, few of you maybe don't even know about it. Then at Telespazio I worked on Cosmos SkyMed, so remote sensing, and then recently navigation at ESA. Copernicus is the answer, the space answer to remote sensing in Europe. Very successful program, supported heavily even by Italy, by the Italian Space Agency, by that Italian industry in particular. And it has to do with the satellites, indeed, the famous sentinels, but also on, in fact, on the concept is really about integration and fusion, because the big source of Copernicus, or big source of data, are the sentinels, the satellites in orbit, but also the so-called the in situ sensors, so the sensors around us, okay? And so I will not maybe speak too much about satellites here, but I will go back again to Internet of Things. Why? Because Internet of Things again, are sensors. Because at the moment you make intelligent an object, and by the way, again, I anticipate, which is the sensor, the source of sensors and sensing that we have. All of us, we are sensors, because now almost all of us have a smartphone. And the smartphone is a mobile sensor, actually multiple sensors. Now, in each mobile, you have the satellite navigation, you have accelerometer, you have a thermometer, and more sensors will add into the mobile. And so we are becoming sensors ourselves, okay? So as soon as the Internet of Things is expanding, and we are forecasting in 2 years more than 50 billion intelligent things around, these are, which is, just to make it 5 times the population, or more the population of the number of people on the Earth. These are all sources of information that is by definition to be connected through advanced telecommunication technology. So the world is changing. We have potentially access to an enormous amount of data. Temperatures, sounds, position, timing, and so on. What can we do about it? So a few years ago, and IoT, as already mentioned, is really everywhere. At industrial level, in our smart cities, and I saw in the program that there will be papers about the future of smart cities based again on 5G and Internet of Things, at entertainment level, automotive level, and so on and so forth. So a few years ago, A few years ago, 2 years ago, I was giving a presentation in London, and I wanted to explain this concept of how we are remapping the world, the reality around us. So I thought about this example. I should have changed it. I should have put the Colosseum. Instead, let's say, just because I'm lazy, not only Lisi, I repeated, I copied and pasted the old example. The old example was based on the map of London. This is a map dating back to the time of Elizabeth the Great, the big Queen Elizabeth I. And you see what was London at the time, so it is 500 years old. The London at the time, the Thames River, and you can also notice the London Tower on the right bottom of the picture. Fairly accurate map, I have to say. Okay, if you think that it was based on just on paper and observation of the people, it was fairly accurate. Today, we would have this, Google Maps. Okay, and here you can in fact have a much more, well, first of all, a very detailed picture of the situation. By the way, you recognize some of the places. You still see the London Tower there. But you can add a lot of more information. For instance, the name of the streets, and you can add the monuments, and so on and so forth. Today, I would not even say tomorrow, we are going to have around that area literally thousands, tens of thousands, or hundreds of thousands of sensors. As I said, first of all the smartphones. So all the people that are there potentially are becoming the sort of walking sensors. And then we have the development of sensors, the miniaturized sensor, by the way, is enormous. Today you have receivers, GNSS receivers, GPS receivers that are tiny chips and can be everywhere. You can have miniaturized clocks, atomic clocks. You can have sensors of temperature, sensors of smell, the odor. You can sense whatever you want, temperature, and so on. So in fact, today already, but let's say tomorrow, we might want to know in the London Tower not only the topography, or the picture of it. But I would like to know, for instance, the smell of the River Thames that I can feel being in the London Tower. Or I would like to hear the sound of the famous ravens of the London Tower. You know the legend about the 6 ravens of the London Tower, the 6 birds, black birds, you know, the ravens, that are protected by the geomans, because if they die, the legend is that when the last raven will die, the United Kingdom will die itself. So they have to protect these ravens that are the protectors of the British Kingdom. So you want to know the sound, you want to know, feel the temperature. So we are really getting a completely new picture of the world around us, with all the possible applications, of course. It's up to us to invent the use of this potentiality. Now, speaking about all this data, have to be referenced. Where do they come from? Because otherwise you cannot do anything about it. If I know a temperature, I don't know where it comes from. Now we are speaking about mapping at the centimeter level, of course. Because if I really want to map this room, in this room, the temperature here is different from the temperature there. So we really have to know exactly where the sensor is when it is capturing this whatever information. And also the time, because also time is important. So timing and positioning are very important. And this is again supported by this other infrastructure. It is not only based on satellites, but surely the most common one, the most common technology about positioning and timing is based on satellites. So the first most known is GPS, then followed by the Russian GLONASS, the European Galileo, and the Chinese Beidou. These are, I'm mentioning here, the worldwide system, the global systems, because there are also some regional systems. For instance, the Indian system, very effective, regional, still serving 1 billion people, so regional, so to say, or the Japanese system, that is a quasi-zenith satellite system, that is serving the area around Japan, but those are defined as regional. These are global systems. And speaking about Galileo, Galileo is the European initiative to provide Europe with a system, navigation, positioning, and timing similar to the American GPS. Here in this picture I want to show also a typical paradigm of the modern technology that goes from products, even very advanced. The satellite, if you want, is a system, yes, but in itself, as compared to the overall system, is a sort of individual product, goes from products, ground and space-based, to a system, but the system itself is not enough, because we want to provide services. This is the service orientation I was mentioning before. So around the technologically based system, you need an organization. And for instance, this organization specifically is the European GNSS agency that I was mentioning, is based in Prague. And I happen to share myself between ESA and this agency, where I am the chief technical officer. And centers around that are not guaranteeing, if you want, in a first instance, the technical performance, but the continuity and the quality of the service seen from the users. It's a slightly different perspective, but it's important to understand that technology per se is not enough. We have to think about the use of technology by the users. So, I want, again, everybody knows about GPS or Galileo, if you know already Galileo, as a system to know where you are. Fewer people are aware of the fact that the most important feature of these systems is not the positioning today, but it is timing. Why timing? Because all the big infrastructures, the critical infrastructure of our society today, are based on timing, a very exact timing, and the main source of exact timing is GPS and Galileo and similar systems. If of all the critical infrastructures in Europe and in the United States, all of them would fail, if GPS and the other, and Galileo, should fail together. So the importance of timing is somehow underestimated. Now, on board the Galileo satellites, we happen to fly the most stable clocks, atomic clocks, ever flown in space. Not the most stable in the world, but the most stable flown in space. To have an idea, this clock, specifically the passive hydrogen maser, is wrong by 1 second after 3 million years. So you have to wait 3 million years to have 1 second of error. Remember that the first chronometer invented by Harrison in the 17th century, that was, let's say, the way to solve the famous problem of longitude, we should have another maybe presentation on the matter, was guaranteeing 1 second per day. Today, when you buy, another little parenthesis, when you buy a mechanical Rolex, if you can afford it, and you read the chronometer, superlative chronometer, the mechanical Rolex guarantees 1 second per day, okay? And maybe a normal electric watch based on quartz can guarantee 1 second per year. This one guarantees 1 second of error after 3 million years. Why? Because otherwise you wouldn't get the precision in positioning. But then you also have a source of very stable, the most stable source of timing that you can imagine of. So much so that in fact we are flying not a constellation of satellites, but in fact a constellation of very good clocks around the world. Okay? And the result is that today already, GPS and now even Galileo, they are broadcasting the UTC, that is a universal reference for time. All the infrastructures of our society are synchronized through GPS and Galileo. And which are the infrastructure? I mentioned some. First of all, the telecommunication infrastructure. By the way, again, the experts here tomorrow, the day after tomorrow, might explain how important is synchronization for 5G, which is almost also natural, no? Because if you increase the data rate, etc., so you might think that timing might be important. But also other infrastructures, the electric power distribution network, which is now getting more and more worldwide, is essentially based on synchronization. If you do not guarantee at each node of the electric distribution network at least 1 microsecond, which I tell you is not obvious to guarantee, and this is obtained through, again, receivers of satellite signals, you do not have a good working electric power distribution networks. When you see the big failures, the blackouts, they are most of the times caused by bad synchronization. So the synchronization is important, but also the air traffic management system, and last but not least, very important, all the financial transactions. I showed there an ATM, but all transactions today need to be stamped very exactly on timing, because the stock market, for example, works at microsecond level. After 1 microsecond, people lose millions, if not billions. So you have to be very precise. So timing is essential. So how important for 5G, for this new mapping? Positioning, sensing, communications, positioning, but also very important, I would say, essential timing. So we have positioning and timing technologies. We have 5G, advanced telecommunication technologies. We have Internet of Things, and if you want, also satellites, in general, the world of remote sensing, generating huge amount of data. And then, of course, you also have to process this data. This is important. Diffusion, in my title, has to do with an intelligent use of data. Otherwise, the data themselves do not speak and don't tell you anything. What is the result? The result is we are the caravels. They are the caravels towards a new world that is sort of surrounding us, opening completely new applications. It's all up to us, let's say, to invent the way to use this new representation of the world. Sorry. And it is a world that is providing us a picture of the reality that paradoxically is more real than the reality itself. I mentioned here the famous writer and poet Borges, Argentinian poet Borges, who in one of his books he spoke about a sort of mythical kingdom where the cartographers were so precise, they were producing maps as large as the territory they wanted to describe. Now we are going almost beyond that. We are giving, enriching the reality with information that our senses, natural senses, will not be able to capture. So we are really enhancing our capability to understand the world around us. About let's say, the organization of these infrastructures. The global navigation satellite systems infrastructure is already multi-constellation, so it's already a system of systems. As I mentioned, there are GLONASS, GPS, Galileo, Beidou, and maybe other regional systems. And we have to think that in the future there will be a federation of these other system of systems. The main ones, but there are other infrastructure that can add to these three, are telecommunications and sensing. And so, what is the result? First of all, a conclusion. We saw that all the goodies, all the good benefits and the good results are not based only on one technology. 5G alone, very good, very nice, but what do you do about it? Do we need 300 gigahertz of frequency and several tens of gigabytes? Yes. Well, why? Because, for instance, we have to transmit and exchange data coming from IoT. So there is another technology involved. Navigation and positioning, exact positioning, and is it important? Yes, to go around with your car, but then no, because then to give a reference, geographical and time-wise reference to data, you need this system. So one single system or technology alone doesn't solve your problem. The users, our society, needs solutions, and solutions do not come, and this is a lesson to the ground companies and also to the satellite companies. So we cannot today say, I have the solution, it's based on satellites, or I have the solution, it's based on, this is no longer true. We have to think about a federation and integration of technologies. The integration and fusion of different technologies and systems makes also these federated systems more robust and resilient, because there is a sort of intrinsic redundancy. If GPS fails, I have Galileo today. At the beginning, there was only GPS. Okay? If Beidou fails, we have GPS and Galileo. So this is the reason why we have to look for a cooperation and an integration of these systems, because somehow they support each other. And then the conclusion is we are sort of mapping anew the world around us. We are creating a sort of new picture, a new world around us. And this is, I didn't mention in my explanation, in my presentation, some important results of this revolution. For instance, in additive manufacturing, the additive manufacturing goes in the line of civilization and dematerialization. Because with additive manufacturing, we are going to exchange no longer physical products, but IPRs. So tomorrow, you'll see in a catalog a nice object, whatever, a knife or a spoon. I like it. Today, you go to eBay, you buy, and they ship it to you. Tomorrow, you go to the equivalent sort of IPRs, eBay, call it whatever. You will pay, and you will download, as you do now with the songs, the digital representation of this, and you feed it in your own additive manufacturing, your 3D printing, and you get it at home. This is going to be the future. Same revolution is in autonomy. It's not shown here, but autonomous driving for cars, first of all, but UAVs, drones, even robotic vehicles for industry, etc. is again going to be a huge revolution. Why? Because in a few years we'll reconvene together. Maybe Michele will organize again another conference. And you'll see that in a few years, I expect less than 10 years, much less than 10 years, people will start not owning any longer their car. Because it doesn't make sense. With autonomous driving, you are going to use the car on demand. It doesn't make sense. With enormous advantages, I'm sorry that the professor from this morning is not here, because that would be a big saving in energy and CO2. Okay? When I wake up late at morning, you wake up very early, we are going to share the same car. Even if we come to the same conference, you come earlier than me, so your car will have all the time to bring you here, come back, pick me up, and come again. So this is saving, and imagine all the saving in parking and so on. So this is a big revolution again that is heavily based on these important technologies, communications, positioning and timing, because we have to know where the data come from, and all the huge, huge world of sensing, of sensors around us. And this is the end of my presentation. And that's it. So, no formulas, because after lunch formulas would have been difficult to digest, let's say. Okay.
Any question?
Okay, Marco Lisi, thank you for your interesting presentation. So it's very interesting to discuss integration and fusion of PNT, remote sensing, and telecommunication infrastructures. So can we realize the three different functions in the same satellite? If we can do so, the integration and fusion is realized on board or in the gateway. Three different functions. Okay.
So if I understand, I'm not sure I understood, but you want to ask where the fusion should happen. I think I should answer saying that it depends very much. By the way, this role or responsibility of integrating and fusing is very much on the application providers and the lower level service providers. I think at the infrastructural level, we have to guarantee, let's say, the 5G people or the satellite people together with 5G on one side, the GNSS people, that they have to guarantee their infrastructures work very well. It's again like for the electric power distribution network. The people responsible for the distribution of electricity, they don't know what you are going to do with electricity and the way you are using at best. They have to guarantee that when you plug in, you get electricity. And the same should be, first of all, at infrastructural level. Good infrastructures. But again, I speak about infrastructure, means that you have to guarantee not only the technical performance, and I want to be clear, because many people accuse me to say, but you are a traitor, you are betraying your engineering profession. No, because the technical performance is essential, but it is a prerequisite. If there is no technical performance, what are we speaking about? We are not even speaking about 5G or GNSS. So technical performance and good engineers is the most important thing, but it is starting. Okay? Then you have to develop all the organization. It's, again, another different type of engineering. By the way, I forgot to say, in the past, and I hope in the future, I worked with Professor Luglio and Professor D'Ambrogio, who is not here now. Here. Ciao, Andrea. Just on these aspects of system engineering and the new branch of system engineering devoted to services, called service system engineering or service science, that has to do really with the way to cope with, to manage a service, a system oriented to services, very heavily technologically based. So it's not that they are simple systems, they are very much based on technology, but in order to provide a continuous service. So getting back to your question, first of all, we need to have good infrastructures. And then lower level, downstream, application providers will develop the fusion. And then the fusion can be on ground, maybe on board. This will depend on the type of application. But to start with, top technology, good vision of the service orientation, and then when quality is top, then you can do a lot of things afterwards. I hope I answered your question. Well.
Excuse me, thank you for presentation. In the last slide, a good slide for the language, last slide. Thank you.
Sorry, the last one, sorry.
Thank you.
Yes. What is it? Sorry. There is a mistake.
Are you?
There is a mistake.
You have.
This is again a limit of the infrastructure. It's Google that was wrong.
You have a vocabulary of thank you by more language. But
which one is missing?
But no Persian, Farsi. متشکرم.
Actually, I was at least a big manager. Then action on you, because big managers do like that.
Oh,
The action is on you. Send me the email with the thank you in Farsi.
Yes, another language after Persian, Turkish.
Send me also the Turkish one. I cannot put all the languages of this world. I'll do it. Send it to me, I will do it.
Thanks.
Okay.
I have just a comment. I don't know if it's appropriate, but evolving the technology does not exclude that in future satellite system there could be an integration of functions. So communication and navigation perhaps and so on. Or the miniaturization and the reduction of dimension and energy saving and so on.
I had to simplify, no? So you know, for instance, on board Galileo, there is a very important payload that is the search and rescue. Again, I should need another hour maybe to speak about it, but it is saving a lot of lives. It is working very well. We had a conference just a few days ago in Prague, by the way, just about the results of search and rescue. So integration is also happening at satellite level. Thank you for reminding me.
Okay, I have the pleasure to give you this.
Thank you. Thank you very much.